Okay, I think it's 4:45, which I think is when we're starting. I want to be prompt. Everyone's been really prompt in this conference, so I don't want to be the first one that's not. I hope you guys have had a great conference. It's wrapping up. I've had a great week. This is probably the smartest group I've ever been surrounded by, so I think I'm going to continue coming to these because they always say you want to be the least intelligent person in the room. Today we're going to talk about programming and building interfaces for kids. So a little bit about me. My name is Sara. I live in New York City. I am the CEO and co-founder of a company called Jewelbots. I'm going to tell you a little bit about what we built, how we built it, and why we built it, who uses it. So today's talk is, so we're going to talk about why I think this group of people is important that we build for and why it's important that we make technology accessible for them. I'm going to show you guys some magic. We have some special guests here today. We're going to do a deep dive into the tech behind Jewelbots. It's actually pretty high technology. And look into how we built an accessible API for C++ for kids. So first I have some questions. Raise your hand if you were under 20 years old when you learned to code. Whoa, look around. Okay, keep them up. Keep them up. Put your hand down if you were over 15 years old. Okay, put your hand down if you were over 13. Put your hand down if you're over 11 when you learned. So wow, so look around. So there's about 10% of you left of people that learned to code before they were 11, which is interesting, right? This is something I learned when I started talking to my peers. So I've been a software developer for 16 years. I worked in the field 5 years before I worked with another female on my team, and it was another 5 years after that until I worked with another one. And I was bummed because I really love doing this, and I think this is an awesome career, and I think that this is something that lots of people should know how to do. And so the bug bit me, and I was like, I've got to figure out a way to get more women doing this because it's amazing. And so I started a nonprofit in 2010 that taught adult women how to code. Girl Develop It is in 50 cities, and we've taught almost 100,000 women at this point. But one thing I heard from many of our students was I didn't know what an engineer was until I got to college. And by then it was too late. Other people already knew what they were doing, and I didn't want to inject myself in something I knew nothing about. So I decided to start taking a look into this group of young girls, why some men are learning when they're younger, why aren't the same thing happening with women? So some things I learned during my research were really interesting. So this demographic of people is one of the most influential demographics. And that sounds crazy to most people, but I'm going to show you a little bit about why. Raise your hand if you know who that guy is. Everyone know that guy? All right. That guy used to be this guy. Until 19, 14-year-old girls discovered, wow, he's a teen beat and he is the best and he's going to be a celebrity. And that's why we know who he is today. What about this guy? Okay. Well, this guy used to be this guy, and I can say that I, not single-handedly, but I was definitely in the group of young girls that made this guy into a big celebrity as well. Taylor Swift, I mean, we don't have to argue. It's not men in their 40s that are like, such great music. I mean, you still do, but yeah. But even bigger than that, platforms that you and I use every day, Instagram, Snapchat, Musical.ly, they're the early adopters for these platforms. We're not the ones discovering them. They won't tell you that unless you talk to people that work there, because that's not technically legal. But it's kids that's finding this. It's kids that are finding these things and making them into huge successes. So why don't we give more respect to this group? We know that all professions, every conversation that we've had this week is how much more technology is being built, how many more technologists that we need in the future. However, this group Still, to date, 18% of computer science graduates, 19% of AP computer science test takers, 15% of Google's technology group, and 51% of Americans are female. So why is that happening? So I did a little more research. So first of all, boys get the coolest toys. So boys' toys are all about building and creating and inventing. And there's stuff for all ages, really, especially that preteen range. There's some brands that really own it, especially Nerf. Nerf is probably the biggest for that group. But there are some more advanced Legos. You start playing with helicopters, things like that, the handheld devices. Looking at the things we build for boys, we send a really clear message about what we're trying to teach them. But when it comes to the things that we build for girls, they're consumables. They're not, they're here, play with this phone, or here, have this tea set. It's not like you're going to build tea sets when you grow up. And also, in that age 9 to 14-year-old range, there's not a lot of products, and there's definitely nothing doing well. I contribute that to the fact of girls much younger are giving up dolls. So it used to be that, almost up until high school, you would play with dolls. And now, younger and younger, they're getting over dolls, and they're just turning to smartphones. And there's no products really for that age group, which is something we found as an opportunity. So we talked to 200 girls, and let me just tell you how fun that was. So the way we did that is we started talking to teachers, and we were like, let's do some introduction to programming classes for you guys. We know you don't have any resources. And in exchange, we're just going to ask your students to answer some questions for us. And we went in there, and we heard some really cool stuff. My first idea was I was like, okay, here's what we'll do. We'll make a bracelet. It'll change color to match your outfit. So you wake up in the morning, like, I want to wear blue. I'll put on my blue, program my bracelet to be blue. I was like, this is what they'll love. And so I started running that past them, and they were like, that sounds stupid. I would never wear that. And we were like, oh, okay. It's a great age group because they'll tell you exactly what they think. And so when we started talking to them, and the thing that came up over and over and over again was just friendship, right? Like, my friends are so important. I spend all this time with my friends. This is my best friend. This is my other best friend. And so that theme kept coming up, and understanding that that's a time in their life when they are developing those friendships. And they are already, all of them were wearing friendship bracelets, the analog kind, but still friendship bracelets. We were like, okay, well, maybe this is what we do. So we're a small team, but we spent a lot of time whiteboarding, kind of thinking about what this device would look like. And what we landed on were Jewelbots. So Jewelbots are smart programmable friendship bracelets. There's an active online community where girls can share code that they write. They let you send secret messages to your friends. So basically, out of the box, they're still super fun. Things like Minecraft and MySpace and Neopets and all the things that have inspired coders to move on to become software developers, they all start fun, and then you can code them. So we thought that part was really important, right? You don't have to code them out of the box. Often parents are like, well, what am I going to do when my kids use Jewelbots to cheat on their tests? And I'm like, if your kids are writing C++ to cheat on their 7th grade English test, then that is awesome. And so we tell them that they can give their devices superpowers with code. So long prototyping process. So it took us 3 years to almost 3 years to get to the point where we were able to ship product. We learned a lot from people who had done this before. That's just kind of like an iteration of all the different designs we went through, the different bracelet types we thought about. We learned all types of things, such as it turns out wrists on kids are all different sizes, right? There's not one size wrist for kids. So some of the designs we thought from the beginning were a good idea weren't. And then other things, it was we heard from parents, oh, that looks cheap, I wouldn't pay for that. And so that was other input that we got as we were building. And so that's kind of like the looks like. So what we learned is when you're building these things. I know not everyone here has built a consumer product. I'm sure a lot of us have played with Arduino. It's not the same. I thought it was, which is why I started to build a consumer product, but it turns out to be much, much harder. So we start with like a looks like prototype and a works like prototype. So works like is like your Arduinos making something that works like what you ultimately want to build, and then you make something that looks like what you want to build, and then the prototyping process is just bringing these guys closer together. So while we're iterating on the look and feel of the outside, we're iterating on the look and feel of the inside too, which I'll show in a second. One thing to note is I hate the flower. So we came up with dozens and dozens of designs for the initial thing. And from the beginning, we've always been like, these girls decide what we build. We're not going to decide. So dozens, pinwheels, stars. We had everyone vote. The flower won by a landslide. Nothing was even close. And I was like, man, now I have to build a programming product and tell people it's going to help girls code. It's a flower, and everyone's going to freak out. But so far, everyone's been really great about it, and people love the flower. So this is what the inside kind of has looked like as we've been building it. We've got some, it's been really big and big battery, and then it's gradually gotten smaller until we can, until now we've got this little guy. And I'll talk a little bit about more like how we've distributed and how that is done in a few minutes. But now I think it's time for a demo. So as I like to say, some magic. So raise your hand if you're coming to the workshop later and you'd like to be friends with me. Okay. All right. You want to come up, Michael? So great. Okay. So this is a Jewelbot. So we're going to play with our Jewelbots. We're going to pair ours. So we're friends now.
That was so easy.
So easy. I'm getting married in New York next year, so you're going to be able to come to that?
Absolutely.
Okay, great.
I am now.
Yeah.
Does it matter?
Yeah. No, it doesn't matter. All right. Okay, so we're going to pair ours so we can be friends.
Okay.
So the way we're going to do that is we're going to hold down the center button for 2 seconds. 1 locomotive, 2 locomotive. Great. And now what's happening is they already found each other. So now we have to pick a friendship color. I'm going to pick, which one do you like?
This is almost too much stress. I don't know. That one.
Okay, so what happens is now I picked green for our friendship color. So now this guy is telling this guy, okay, we're going to be green. And now whenever Michael and I are together, we're going to be green together. Yours will light up in a second. So awesome. So now you're green. Okay, great. So you can go sit down. We'll need you later, but you can go sit down. Yeah. Okay. So that's the friendship functionality. We need one more. Someone that's coming to all right, in the back. Imagine we're in middle school.
Not too large of a jump.
Yeah. I'm Sarah.
Hi, I'm Nicole.
Nicole, nice to meet you. You can come to my wedding next year as well? Okay, great. Okay. Let's get this off. Okay. So we're going to do the same thing. So you're going to hold down the center button. Make sure you hear a click. Oh, whoops, you just turned it on, sorry. Yours was off. Okay, now you're going to hold down the center button for 1 locomotive, 2 locomotive. Okay, so now they're finding each other. Oh, I'm controlling it again too. What color do we want to be?
That one.
Okay, we're going to be red. So now my guy is saying, okay, we're going to be red. And your guy is going to say, all right, we're red. And so what's going to happen is yours is going to be red. Mine is going to be green and red. Because the way we want it to work in a way, this is kids. So we wanted to make sure they're definitely giving a thumbs up to the fact that they're pairing. So Nicole, you can go sit down and you'll call you back up later. Okay, so that's how Jewelbots work out of the box. We can send each other messages, things like that. But I am not the leading expert on coding them. This is my next favorite. I learned about this later. So if you ask me about the fact that I would be giving talks with kids talking about C++ a few years ago, I would have told you that's crazy. But I'm here to tell you that it's not. I'm going to introduce our first special guest today, Sumaya. Sumaya is local to the area. She's an amazing coder, acquaintance, friend of Melinda Gates, an awesome community activist, and she's going to come talk to you a little bit about Jewelbots.
Hi, I'm Sumaya, and today I'm going to talk to you about Jewelbots. So, Jewelbots is a programmable friendship bracelet that is aimed at girls in their preteens and teens. It is really a great introduction to STEM, especially if you're a beginner like myself. And you might be wondering, what is a friendship bracelet? A friendship bracelet is basically a way that girls can share a token of their trust and signify their friendship by mixing and matching bracelets. Jewelbots is like that, but better, because you actually can program it. And you can speak with your friends with Morse code via Bluetooth. Jewelbots is programmable using the language C++. Here is an empty sketch in Arduino IDE. And Arduino IDE is a service for developers who can program using Arduino boards. Here is actually an example of the first code that I ever wrote. Okay, so now that you know a little more about Jewelbots, let's talk about some of the components. There are 5 main components. You have your LEDs. So LEDs are basically the lights that are turning on your Jewelbot. You have your timers, which you can use to control your code. Animations, which is when the LED can actually, pulsate in a sequence with one color, like it could be blue or green or magenta. You have buzzers, which are basically when the Jewelbot buzzes. And then you have buttons. I forgot to mention the Jewelbot's a haptic device. But then you have buttons so that you can press a button and then your code will enact after that. So now that we've talked a little bit about that, let's talk about the code you can actually write using these components. So here is a Pomodoro timer that I wrote. And in the arrows, you can see some of the components I was talking about. And if you don't know what a Pomodoro timer is basically the idea of 30 minutes of work and then a 5-minute break. This is really great for a student such as myself because sometimes you have that big homework assignment, but you still need to take that break and stretch your legs and maybe check your phone. So here is a much more shortened example. This is shortened to 5 minutes. But basically, every few seconds, it's going to flash green so that I know my timer is starting. Okay, so let's actually write a hello world. Okay. So you'll notice there is setup and loop. Setup is basically where you're going to have your code, but it's only going to run once. Loop is when your code will run an infinite amount of times as long as the Jewelbot is on. Today we're going to write in loop. So first we want to declare our variables. Timer, okay. And now let's call our function. So we're just going to write a simple little turning on the lights. So LED, turn on all. Okay, and then timer. So we want to choose how long the lights are going to stay on because otherwise they're just going to turn off really fast. So let's do 5 seconds. But you'll notice, so you might wonder why there are 3 zeros. Well, the Jewelbot timer understands it in milliseconds. So the way we're going to write it is it's really 5 seconds, but we just have to add those 3 extra zeros for our code to work. So now we want to verify our code. Uh-oh, we have an error. So as you can see, this is a colon instead of a semicolon. Oh, oops. And so now we're going to verify it again. And as what? Oh. Oh, I see. Sorry. Sometimes. Oh, yeah. Okay. Sometimes we make errors, so, okay. And now you can see that it works. So if we were going to do this normally, we would upload it, but I don't have my Jewelbot plugged into my computer right now. Let's look at timers. So as I was talking before about Pomodoro timer, I'm just going to walk through the code with you. So you'll notice that actually the code is not under setup or loop. When you're incorporating button press, you're going to put the code under your button. So as we have all 5 of the components we were talking about before. How it's going to start is that we have timer pause 1 second after we turn on the Jewelbot, and then it's going to buzz 4 times because we have a for loop. Then after that, it's going to buzz 4 times long. So now we're knowing, okay, our code is activated, and it's going to turn on all green. And then for about 30 minutes or so, every 30 seconds, it's going to flash green to show us that, okay, our code is still working, and our timer's still going, and we still have to focus. And then we can check our phone. And at the end, we have an animation breeze single color blue, and I did explain animations, but I'll just explain them again. So animations are basically when the colors your LEDs are going to pulsate, and then it ends, and I know, okay, now I can take my 5-minute break and stretch my legs. Let's go back to our presentation, though. So now that you know a little more about Jewelbots, I'm going to talk to you about why I personally love Jewelbots. When you buy a Jewelbot, you really are becoming a part of a really great community. Becoming part of Jewelbots, there are so many people who are so excited to get girls into STEM and to learn about STEM themselves and really just learn how to code. I know that through Jewelbots, I've even made friends, such as Eleanor right here, and I really got to learn how to code and be part of the coding community. In fact, once Sarah and Quimby had a Google Hangouts, and we really just got to learn actually how to code a game together. So it's really just a great community. I also love Jewelbots because I get to code with my dad. So my dad is a computer programmer, and I've never really understood what he does. I mean, I knew he codes, but I didn't really understand what he did. And through Jewelbots, I've got to understand that a little better and learn what he does in programming. So this is us programming for the first time, programming Jewelbots for the first time together. And then we actually share our code. So are there any Whovians in this room? Woo! So this is us at the Dr. Who convention in Seattle. And you can't see it here, but we actually programmed our Jewelbots so that they would flash white and blue, like the pulsating colors of the TARDIS. So now that you know all this, maybe you want to check out Jewelbots, maybe you have one, and you just want to learn how to use them or cool things you can do. So I have a few sources. So I was talking about the community. There's the community forums where you can talk and you can share code. Sometimes they even have fun questions, like once they had what's your favorite show, what's your favorite color. You can become an ambassador on there, so totally check that out. There's the Jewelbots zine, where they actually have a magazine where you can look at a bunch of cool things. I actually got the chance to tell my story in one of the recent issues. So you should totally check those out, and you can learn about apps and a bunch of cool STEM-related things. There is my blog, Bits of Code and Imagination. If you know a girl or have a daughter or a teenager who really is into coding or has a Jewelbot, you should totally go check out my blog because I talk about different programs you can write, and I explain a little bit about Jewelbots. I actually have a fall program coming up soon, so you should totally check that out. And then there's Laura and Luisa's learning blog, where I learned at medium.com, and you can learn about functions and variables there. So I hope that with what you've learned from my presentation and Sarah's presentation and Eleanor's presentation, what's coming soon, that you will go tell others about Jewelbots, maybe get one yourself, and really #code like a girl. Thank you.
I'm Eleanor, and I am a Jewelbots ambassador. So I also am a competitive swimmer. I travel the world a lot, and I also play lacrosse. So what's an ambassador? A Jewelbots ambassador is a user who uses Jewelbots to spread the word to other girls and to get them interested in coding. But why Jewelbots? Why not teach girls how to code the same way that we teach boys how to code? Well, Jewelbots is made by girls for girls, and it's specifically made to teach us in a way that interests us, like through friendship, like Sarah and Sumi already explained. So C++ for kids? The Jewelbots Arduino boards are very easy to understand, and even kids of the age of 8 have already learned how to code their Jewelbots. And even if you don't understand it very well, they have instructions on their website that you can use if you need help. They have 2 different boards, which is the solo coding board, which I'll explain in a second, and the friendship coding board. The solo coding board you use by yourself if you just want to code your Jewelbot to not react when it's around your friends. And then the friendship coding board you can use to you can use your code and make it so that when your friends are around and it's that specific color group, it can your code will run when you're around them. So let's talk about the solo coding board. There are 5 different functions, like Sumi already explained. In the LED function, you can code the 4 LEDs to light up individually, or you can code them to light up all at once. There are also LED animations, which she already explained, but there are 2 others, not just the breeze single color. One is an animation that's based off of the Jewelbots logo, where it flashes their colors and buzzes. And then there's also the rainbow sequence, which just flashes a ton of different lights in a rainbow. And there's also the buzzer function, which Sumi already explained, where they have preset buzzer functions which you can use, whereas they can code for different amount of times. And there's also a custom buzzer where you can choose the strength at which it plays and the length. There's the timer, which is pretty self-explanatory. You can choose it to make breaks in your code, and to keep LEDs on for however long you want, and then make them turn off. And then there's the button, which Sumi already explained, and where you can your code will run when you press the button. So the friendship coding board is pretty much the same as the solo coding board, but it runs when your friends of that specific color group are nearby, and it uses if-then statements and Booleans. So here's some pictures of my code, and there are some examples on there. For instance, over here, I'm turning on different LEDs. They're all on at once, but they're all in different colors. So this one's kind of meant to be like seeing the cycle of the sun and the moon rise. So the yellow represents the sun, and the blue just represents the sky. And eventually, the yellow, instead of being yellow, it just turns white, which is the moon. This is one of the programs I did a while ago. I'll show it in just a second. And then this one's my most recent code, where it uses the friendship coding board to, whenever your friends in that color group are nearby, it's kind of like a doorbell. So it flashes in one color, and then it flashes in the other buzzer, and it buzzes when one light's on, and then it buzzes when the other lights are on. Oh gosh, I'm on the wrong slide. Oh no. So here's some of my code in action. These are videos, and this is my first code that I ever made, where this was way back when we had just started out, and I think that we had to work through making all of the LEDs light up at once, and I had made these 2 light up blue, and these 2 light up red. This is the code that was in the middle on my other slide, where it will hopefully have I don't think the sound's on, but it buzzes and lights up in different colors, and then eventually it'll light up in the Jewelbots animation. And then it'll light up in other colors again. And then this code is the code that I just made, where it's the cycle of the sun and moon. I think I accidentally filmed it when my Jewelbot was upside down, so it's kind of going in the wrong direction. Is it gonna play? Yeah, I don't think it's gonna play, but yep. But I think that the coolest thing by far that Jewelbots has done is made it so that kids of the age of 8, and some even a little bit younger than that, know how to code now. And I think that that's just really, really cool, and I hope that you guys all think the same. So this product is amazing, and I'm glad you guys all came to this, so bye.
So they show you how they work and how they get coded. So I'm going to tell you a little bit how we approach design and building an API for kids and making sure it was accessible for everyone. So a little bit more about the technology. These are a whole bunch of different plastics and nylon. The cap is made with injection molded plastic. And the body is made with like a weird CNC process I don't quite understand. And the hardware lives inside. The bands are interchangeable. You get some different colors, which is neat. Hopefully, down the road, we want to make all different kinds of designs. So, and then inside, we've got a button, 4 RGB LEDs, a USB input, and this NRF 51822. And let me tell you the story about how this became the chip that we used. This is from someone who here has built hardware, like consumer hardware. Yeah, this is probably the most people I've seen at a conference. So that has actually done that. So let me tell you the story here. So I was at a sales session with a Nordic representative, and I knew what we wanted to do. I knew it was really important that there be a device that connects to a bunch of other devices. And I had heard of this Intel chip that could do 3 simultaneous relationships, either peripheral, either serve as a peripheral or serve as a central device. And this guy told me about their new chip, which allowed you to make 8 simultaneous relationships, both central and peripheral, which is nuts. I was so stoked about that. And I was like, this is it. This is our chip. Here are the things he did not say. He did not say that no one had used it in production. It was not even in alpha yet, and it wouldn't be for about 2 years. So we include this on all our designs, and when we were helping them debug data sheets the whole time, like just being like, oh, so this doesn't work, and they'd be like, oh yeah, that's totally wrong. Sorry, we've known about that, but we're like, okay, well, could you tell us? That would be great. So that was an adventure and a half. So just more of the details of what's on the microprocessor. It's super small in here. It was important that the device, fit on wrist, so we had to go something super tiny. The microprocessor is 4 millimeters by 4 millimeters, super small. The joke I make there is always you could eat one, you would never know. You would never know that you ate it. But this tiny guy can do lots of really interesting things. So the capability here is really neat. The Jewelbots had the same capability as an Apple Watch, just doesn't have a screen. Not the new one, though. It can't make phone calls. It kind of ruined that for me. So it can connect to a bunch of other Jewelbots at the same time. It could connect to your Amazon Alexa. It can connect to your phone. It can connect to a drone. Worst way to control a drone, but who knows what your life is like. But right now, we're limited to the functionality that we showed you today, and I'll talk a little bit more about how we designed that. So Jewelbots pair to each other using BLE. They react to other Jewelbots and they're in range, as you saw before. They enable you to communicate. So in order to send a message, I just hit a button, and it rotates through my different friends that are nearby. So I'm going to pick my green friend. And somewhere in the next 30 seconds, tell us when you get the message. Yeah, okay, great. And you can code them using the Arduino programming environment. So rather than write our own IDE, which is an insane thing to do, we wanted to use something that people might be used to. So Arduino is one of them. We're working on Visual Studio support. Visual Studio just added Arduino stuff, and we just need to know that our boards work with Visual Studio, so that's something down the road. we just rolled out the Jewelbots app, which is pretty simple right now. It makes the setup for your devices easier, so you don't have to be in front of a computer. The instructions that come with the Jewelbots basically say, here's how you turn it on, go on the internet to find out how to set it up. Because when we had to finalize instructions, we were still building firmware. So we were like, man, we don't really know. We hope this works like that, but we don't know. So our instructions are online, and it's good because we do release like updates. So we can just update the instructions. It's built with Cordova and Ionic. Ionic/Cordova has great support for Bluetooth, is the thing. There's really neat libraries that allow you to do great things that are less opaque than the native apps. So that's why we use them right now. It's only on iPhone. Okay, so for those folks that haven't done this before, basically the microprocessor lives on a bigger board, like you saw, and there's components all around the board. The microprocessor sends communications to all the components on the board using electricity and patterns and a timer, which sends certain messages and tells it when to go on and when to turn off. And so that's basically how that part works. And so that's the really low-level stuff. And then a level on top of that is C code. And the reason why we're using C is because this is a tiny chip and there's no room for a compiler. So we can't use things like Python or anything like that. That would be easier to write. A lot of programmer parents, none at this conference, because you guys already know this, other conferences will say, why don't you use like Ruby on Rails? It's so much easier for kids. And this is why. So you already saw on how the LEDs work. But the code for making this firmware looks like this. So basically, no matter what component you're using, you're sending this type of message to tell things when to turn on, and that uses the same function to turn things, send messages back to the microprocessor. So this is what we were going to open up to kids. We did not think that this would be the interface to tell people coding for the very first time how to code. So knowing that this is what we were working with, we did our own level of firmware in order to control the components, and then on top of that added the API that they could control the components. So when it came to things like working with LEDs, we created a state handler for LEDs, knowing that we would be controlling the LEDs with the next level of code, the C++, in order to give access to the kids. And so that looks like something like this. So we give them functions that have real-world names that sound like English, like LED.TurnLightOn, and things like that. And now as far as different colors, we weren't going to give them the addresses to put in to tell them how to control RGB. So we were like, what can we do? So we picked a series of colors that we thought they might want to play with. I think there's 8. So we gave them access to things like magenta and green and the things that they would want to use often. On my list is like get more colors though, because there's only 8. We also, this was a very heated discussion within the team, and I still think we chose wrong. But instead of, because it was either give the LEDs positions, which I don't think that kids are sitting there being like, okay, north of my device is, or numbers, but I lost this argument, so it ended up being positions. And so when they're deciding which LED to use, instead of, again, giving an address, they're giving things like northeast and southwest and that kind of thing. And then this is, I don't know if you could read that, but that's how we give the API. We give them for LED positioning and the different labels for the colors that they can use in their functions whenever. And that makes something that looks like this. I don't know if you guys can see that. But basically, it's LED turn on single, LED turn on all. This is a lot of the functions that you saw Eleanor and Sumaya talking about. And then I was going to do a coding demo for you guys, but you've already seen that. And so for the animations, we figured that kids would want to write animations, like have things accessible that they could use whenever. And of course, rainbows was the first thing we thought of because they're awesome. And then the ability to let the lights breathe, so we gave them that too. So this is just kind of how we write the code for animations on our end. And then we abstract it out so that they can use just simple commands like animation.rainbows, and then they're ready to go. And then things like the button. It's interesting stuff. So one thing that was the reason why we have two different boards, the friendship board and the solo board, is because, as you saw, the friendship functionality is set up by pressing the button, holding down the button, different things like that. We wanted to make it clear that if you want to be in friendship mode, you don't want to overwrite those button presses to make it confusing, right? Because if you overwrite the button press of holding it down 2 seconds, then the end user expects to be able to still do that. However, they've written code that overwrites and it's not very obvious. So we set that into 2 separate boards so they understand this is the board I use if I want to play with friends. This is the board I use if I want to control everything. And so the board that they code for friends, you have access to much less, as far as you can't do like a long button press or anything like that. And so the only event-based programming is the button. And then in there, they can put different things like LEDs and using the buzzer and the timer and things like that. OK, so now this part is where we're going to go back to our 2 lovely volunteers. So friendship code is my favorite part of this, because you can code your device to react in certain ways for certain friends. So on our end, and the way it works in the Jewelbot, is these guys are constantly just polling the room for Jewelbots. So they're like, is there a Jewelbot around? Is there a Jewelbot around? Is it my friend? And once it sees a friend, that's when it turns on. And so what we figured they would want access to is like the first time I see a friend, or when I see certain friends. So we set up the API so it's, if I see my red friends, do this. If I see my blue friends, do that. So I'm going to exit out of here. I'm going to open up a new one because I think so we give some examples for friend color group. OK, this is a blank one then. Turn the cable. Yeah. OK. So I'm going to code this. So when I see my green friends and I see my red friends, I get a bunch of rainbows. So right here, if you can see, the code says seen green friends and first time green, I get a bunch of rainbows. So I'm going to add these guys. I think I've got too many parentheses there. Great. I'm going to remove this. And then I don't need these guys either. OK. So I'm going to do this, and then I'm just going to add my red in here too. Okay. Let's see, red. Okay, so the way I code my Jewelbot is I take off the cap and I plug in the micro USB cable. So this is what you get with like your Android. And then to put it into coding mode, into a bootloader, so it'll accept code from my Arduino IDE, I hold down the button for 2 seconds until it flashes purple. Colors, like in our design, colors was very important at figuring out what colors mean what. And then just what I do is I first make sure I'm on the right port. Then I upload my code. So this is time consuming. The upload part. The Arduino IDE is something that we really don't have control over. But there's a lot of people working on it, making it better. It's an awesome tool as far as something that's open source and something that anyone can use. So it works like a regular Arduino. It sends the firmware up to the device. Here, I'll make this bigger so you guys can see what's going on. And then once it uploads, actually, I'm going to ask you guys to do this now. Can I ask you guys to go out in the hall until your Jewelbots turn off? Sorry, what did you say? Lights? Oh, you saw lights, yeah. Okay, great. So when it's done coding, you'll get a rainbow, which you just saw. So, all right, once they're gone, I'm going to unplug. Okay. So when they come in, we should get some rainbows. Okay. Okay, you guys can come in. Someone may need to go get them. Yeah. So we see one already.
It's off right now, so
Okay.
hopefully when they come in.
Yeah.
Red.
Rainbows. Okay. Live coding, man. Thank goodness that worked. Okay. All right. So a little bit about where we are now with the product. We have found out that we have a 44% conversion rate from people that just play with these guys to coders. It was a lot higher than we had hoped, but we're really happy about that number. And we've almost 10K units in the next month. We'll hit a 10,000th unit, which means there are 10,000 units in 35 countries right now. So I just did the math for you guys. That's how many new coders we've gotten in the past year. A lot of these coders are for the first time. And then we've had hundreds of folks at these workshops, which are so great, where we all build a game together, and it's for beginners. So this is, anyone here wants to help. There's a lot of things that we want to do. We're a pretty small team. Right now there's 3.5 of us, kind of. One of them is my mom. If you ever have a support ticket, that's who you're talking to. Also, my mom tells me that every support ticket she gets, she prays for whoever it is. So if you need prayer, just email us. So a lot of things we want to do is add social media capabilities to the app, like the things on our list. Like add social media capabilities to the app so you get a push. Like if I get a Facebook message, my Jewelbot turns blue, that would be awesome. We don't think that has anything to do with coding. We think that has everything to do with marketing and like why kids kids that don't have developer parents, that's never heard of coding before, that don't care, will want to have a device like this. New animations are always great. Right now we only have 2. And more games. Like one of the first games that came out of when we first started shipping, we didn't know what was going to happen. Lots of kids play hide and seek with them, because like especially if you're playing outside, it's really great because you'll know that you're like close to the person when it turns on. So like fun things like using proximity to like turn the lights on, you know, like brighter as you get closer. Is pretty fun. I mean, there's also other stuff going. Adults are working on things too, like someone is coding their Jewelbot right now so it deploys to GitHub for them, which is cool. And so neat things like that are possible just because the whole thing is open source, like every level of it from the design to everything. So yeah, we'd love your help, and thank you. There's a happy Sumi picture. Yeah, I think we have a few minutes for questions, right? Yeah. Go ahead.
So I was going to ask, because I'm a little confused about the code with friends versus the code individually. In the code individually, do you have access to, like, because most of the things that we were seeing was just turn, your code was much more like, here's a for loop, here's an if-else statement.
Yeah.
And my question is, as far as the spectrum of complexity in code, is there that ability for them to go deeper?
Yeah, on both sides there are. So they can still do the for loop and things. It's just like things like a long button press. That's in the API for solo coding, but not in friendship coding, so it doesn't overwrite the like the ability to add friends kind of thing. Yeah.
Are you guys planning any future models with additional hardware capabilities?
Yeah, we're working on, the question, I just got to sign this as repeat question. Are we working on any additional hardware models with different abilities? So this is an interesting thing that we've learned. So when we first started talking to girls, especially, we tried to talk to people across demographics and socioeconomic classes. And in the more elite private schools, we'd go and they'd be wearing things like a Fitbit and a Jawbone Up. And we'd be like, oh, cool, like how many steps have you taken today? And they'd be like, I don't know. And we'd be like, all right, like where's the app? Can you tell? And like most of the time they didn't even have the app, or they'd never open the app, or like they never look. And we'd be like, all right, well, why are you wearing that? And they would be like, I don't know, it's like a wearable, it's cool. And we'd be like, okay. So the first model, we did not add an accelerometer because we were like, we don't care. But now when we're talking to them and how fast fashion moves, a lot of them are wearing them. And when we ask them now, it's more like, I wear this because I compete with my friends over how many steps we take. So it's like, she takes 10,000, I took 50,000, I'm killing it. So the next version will have an accelerometer. We're working on some other things too, yeah. Way in the back. Yeah.
So what I was curious about was two things. The first one is like, you know, plugging it in is kind of, I don't want to plug in my devices normally. So like, are you thinking about doing like wireless charging or like some way of like connecting to your computer through like Bluetooth or something and uploading code that way?
Yeah, that was something we talked about a lot in the beginning. We knew we had like the human resources to code one, either like Bluetooth upload or wired. And so we picked wired just so we weren't alienating people that had desktops. However, like that ability is there, so definitely one day we want to code to do it. Yeah.
How long does the battery last, and how do you charge it typically, or it's just a fixed battery?
So you charge it by plugging it in with the micro USB. So full, if it's off, it'll last a week or two, and full lights, full everything going, about 2.5 days. So in between those. And then there was someone in the green in the back, yeah.
So I guess I could go check, but since you said it's in 35 countries, I assume that you have different languages for documentation?
No, we don't yet. Yeah, but we'd love help with that if anyone is interested. Yeah.
That would be fantastic.
Yeah, I agreed. Yeah,
Especially for kids this age that are not quite bilingual. So.
exactly. Yeah.
Are you considering other like visual design, not hardware, but how it looks?
Yeah, the look.
I mean, I can imagine some use cases for myself, but
Yeah. So two things. So we have the schematics for the charm online, and I'll make sure that's on GitHub today. And so you can 3D print your own, and you don't have to do the flower. And yes, down the road, we definitely want to release lots of different, these guys, we call them charms. So we already have designs for different charms, like a robot one and things like that. So yeah, that's definitely on the timeline.
Following up from there, can you put like an LED screen on there or anything like that? Like, not necessarily like Apple level, but just something for text, because I don't really want to deal with Morse code.
Yeah.
I'm sorry, I don't want to.
Yes, no one does. So usually the secret messages end up being like, if I send you 3 buzzes, meet me outside or things like that, like less than Morse code because it's really complicated. However, price point wise, it's really hard to do that. Like doing that and keeping it under $100 is like really, so for now, there's no plans to do that. Yeah. Is there a question in the back? Yeah.
How much are you selling them?
Yeah, this is the sales part. So right now, we're selling them for $69 for 1, $99 for 2, $129 for 3.
So, additional question. Can they light up, like you were talking about different capabilities, like for instance, pushing to GitHub and things like that. Can they be triggered by online events, like an REST-like interface? Like for instance, instead of having it light up when a friend walks in the room, can it light up when one of my friends tweets something?
Yeah, that hasn't been built yet, but it's possible. So that's definitely something that we'd love. Anyone?
What is the distance of detection of those arms?
So it's 30 meters. Yeah. Sorry, what is the distance? Like, what is the Bluetooth, the distance of range? And it's 30 meters. Yeah, last question?
What are the plans for an Android app?
The plans for the Android app are when I can get to the Android app. So definitely it's out there. We're using Cordova, so it's like we just need to make sure everything, like there might be one, I just haven't tested it yet, so like but there's probably changes that need to happen before it works on Android. So we're doing a workshop. It starts at, workshop starts at 6:30. It's in room 409. We have Jewelbots for you to borrow, Jewelbots for you to buy, discount, and between now and then, we're also having some pizza. John, did you want to say something about that, or are you just walking up?
There's pizza ready now. It's California Pizza Kitchen. Just go down here to 6th Street, and it's like 2 blocks, a little more than 2 blocks maybe, and then on the left.
Yeah.
What, Ted?
Bryce is disagreeing.
Oh, 3 blocks, okay.
All right.
But anyway, yeah, they're waiting for us there, so.
Thank you, everyone. Thanks for coming.